outbreak of the COVID-19 virus has affected countless people around the world. People can be infected with this virus primarily by person-to-person contact, by spreading contaminated droplets from the mouth or nasal passages, or by touching contaminated surfaces. In this study, an Arduino-based sensor is used to automatically detect a person and dispense disinfectant through an array of spray nozzles. Our research study is entitled iArm, Innovative Arduino-based Movable Disinfectant Portal. Good day, everyone. I am Micah, and in this presentation, we will be focusing on this chapter 4 to 5. Before that, I would like to introduce to you the other researchers that is also responsible for this study. My group mates, Ms. Calamba, Mr. De La Fuente, Mr. Ruiz, Ms. Talib, Mr. Yurag, and lastly, Ms. Contreras. Before we move on, let me share with you the flow of the presentation. First, we have the documentation, followed by the presentation of data, interpretation, summary of results, conclusion, and lastly, the recommendations. And now we're going to proceed with our documentation during the process of the making the device and the presentation of the product. And in this slide, it shows the purchasing of materials and the making of the disinfecting portal. And it's also in this slide, it shows the making of the storage box for the command system and the programming and testing the device sensors. And lastly, the running simulators for the iArm disinfecting portal. And for this slide, this shows that the device is working. And now let me give the time to Chad for the results and discussion.
Allow me to talk about the results and discussions. This chapter discusses the presentation, analysis, and interpretation of data acquired during the study, with a focus on the effectiveness of the iArm disinfecting portal's 3 command systems and liquid level sensor. We tested the distance covered by iArm disinfecting portal, range of ultrasonic sensor, and both are measured in meters. We also tested the disinfectant reservoir levels, which is measured in millimeters.
Hi, I will be discussing the results of iArm disinfecting portal test. Table 1.1. It showed that with a distance of 0.5 meters, 0.3 meters, and 0.2 meters, the mean value of the people disinfected are 8.33, 8.6667, and 9.333, respectively. The standard deviation for the distances that are mentioned are all 0.57735. The distance of 0.2 meters has the highest mean value, hence it has the most number of samples disinfected. Table 1.2, it showed that with a distance of 0.5 meters, 0.3 meters, and 0.2 meters, the mean value of the people detected are 8.6667, 9, and 9.6667, respectively. The standard deviation for the distances are 0.57735, 1, and 0.57735, respectively. The range of 0.2 meters mean value, hence it is still the most effective range for the ultrasonic sensor to detect samples. In table 1.3, it showed that after 3 trials with levels of 1,300 ml, 1,250 ml, and 1,150 ml, the mean values of the liquid level sensor are 0.6667, 1.3333, respectively. The standard deviation for the levels are 0.57735, 1, and 1.52753, respectively. The level of 1,150 ml has the highest mean value, hence it is the level range of disinfecting solution in which the liquid level sensor detects to determine if the reservoir is running low.
Now, I will discuss the analysis of variance of the mean number of distance covered and range of ultrasonic sensor by the IARM disinfecting portal using 3 command systems. Since p-value is greater than alpha, the averages of all 3 command systems are assumed to be equal. In table 2.1, it was verified that there is no significant difference between the command systems with a 0.05 level of significance. As a result, there is no discernible variation in the performance accuracy among 3 command systems. In table 2.2, it was verified that there is no significant difference between the command systems with a 0.05 level of significance. Therefore, there is no discernible variation in the performance accuracy among 3 command systems.
To test and evaluate the device's functionality and effectiveness. The device has 3 command systems that have undergone 3 trials. The data obtained after evaluating and testing the device reveals that the device is effective. Command systems 1, 2, and 3 on a range of 0.5 meters, 0.3 meters, and 0.2 meters were found effective since they had a mean value of 8.6667, 9, and 9.6667 respectively. The IARM disinfecting portal has no statistically the difference between the command systems and the sensors at the 0.0.5 level of significance. As a result, the precision of the effectiveness of the 3 command systems of the IARM disinfecting portal is similar.
After making the device, series of investigations, and according to statistical evaluations, the 3 command systems and 3 liquid level sensors showed no statistically significant difference. Hence, the command systems and the liquid level sensors performances are strikingly similar. The results implied that the IARM device is found to be effective. This robotic innovation, even with the advent of pandemic, can ameliorate the situation we are currently facing.
Imay kaya ano? Sorry.
Wait lang, ayun sa Surya. Wait lang, mag-go lang ko. Wait lang. Pag Surya sa...
Hello. Recommendations. Number 1, increase the distances to be covered and
Wait
ranges.
lang. Ulit na, God. Ulit na. Pawas akong nauna. Pagulat og 5 seconds. Pag Surya sa, tapos pagulat og 5 seconds, tapos Surya na.
Okay, sige. Recommendations. So, number 1, increase the distances to be covered and ranges by motion sensors by using ultrasonic sensors as motion sensors. Number 2, find a suitable programming software and language. Number 3, increase the number of mist nozzles. Number 4, increase number of samples. Number 5, improve IARM disinfecting portals design and mechanical features.
And this is the IARM disinfecting portal. Thank you so much.